Alright, we're officially recording now as soon as this computer catches up with us. Hey, we're recording. Just caught that one, it's on the thing. Alright, so the square root of x minus 5 as soon as this thing catches up. My goodness. You think this is the first time we turn these computers on?
I actually do. Well, that's your legal first name.
Alright, here's my video game for the day. Might have to do this one more time. Alright.
It's up here.
One more time.
No, it's not. I just saw it.
Alright, yay, we're in business, finally. No applause, just throw money this time. So y equals square root x minus 5. So if you did this on Decimus, basically the graph's going to look like this. 2, 3, 4, 5. It's going to kind of go this way. Of course, if you plugged in points, there's no reason to because you're plugging in Decimus, but this graph looks like this. Okay, so if they ask for key features, they're going to say label all key points, intercepts, max, mins, asymptotes, etc. The only key point that's really on here is that you have one solution to this graph that we see. Okay? Of course, this graph has infinite points all along it, and if we were like in 7th grade, we would make a t-table, but we're not going to make a t-table. We're going to use it off decimal. So there are not any asymptotes to this. There is, it has an absolute min of infinity, but we're looking for a local min or a local max. Nothing else. Okay, what else would you like to see off of 1 through 6? Number 8? Yeah, okay. So, number 8 equals, what is it? X over x squared minus 9. And is less than or equal to 0. So there's 3 key points up here because our denominator will factor to x plus 3, x minus 3. Is that okay so far?
Yeah.
Okay, so things that we will know definitely will happen. If I draw a sine line, if I take into account this, if I make that 0, that makes the whole thing 0. Agreed? So we're going to put 0 is one of my key points. And I'll put a solid dot. The reason I'm putting a solid dot is because I have that right there. Is that all right so far? Then, because I can factor out the denominator, this would yield me -3. Okay? And I'm going to put an open dot there. The reason I'm putting an open dot there is I plug -3 in. That makes my denominator 0, which is a big no-no. And then if I plug this point in right here, this tells me that +3, it's a critical value, but it's not going to exist on our graph. Okay, so sometimes when we're doing this kind of problem, if we don't have a calculator that we're using, which you will, but if you didn't have a calculator, you have to figure out certain things are going to take place. It could be positive to the left of 3. It could be positive between 3 and 0. It could be positive between 0 and 3. It could be positive to the right of 3. It also could be negative at any of those quantities. So did anybody graph this graph? Did anyone get a graph of what this kind of looks like? Anybody?
What page is this?
Review 2 or review 1.
Review number 1.
It's number 8.
Parabola?
Not a problem.
I got the squiggly thing.
Squiggly thing?
Yeah.
Is it on your, can I look at your phone?
Yeah.
Okay. So it does this. Let me look at my short-term memory as well. And then it's up here like this?
Yeah.
Or is it down here?
It's up there.
It's up there like
Yeah.
this?
Yeah.
Okay. Alright, so that's basically what the graph looks like right now. So a few things that we need to worry about as far as the graph goes. This -3 is over in this region. This +3 is over in this region. This is my 0. Okay? So over here on this side, it's going to be negative. Why do I say it's negative on the left side of the 3? What's the graph doing? Where does it exist? Say below the x-axis. Good. Now between 3 and 0, what's it doing? Is it above or below the x-axis? Between -3 and 0, above or below?
Below.
Look at my graph. Above. It's positive here. Between 0 and 3, is it above or below? Below, and then on the right side of 3, it's all above it. Okay, so that's kind of what our sign line's looking like right now. So if we were to do it as a sign line, there's other things that we're going to indicate on this right now is let's talk about vertical asymptotes. That's where the denominator equals 0. Okay? So at x equals -3 and at x equals +3, that allows my denominator to become a 0. So it's kind of like right in here. That's your -3 right there. And then here's my +3. Okay? There's my vertical asymptotes. But there's a horizontal asymptote, but this is a goofy scenario. It's a goofy scenario because in one spot we do cross our horizontal asymptote. But what was the rule yesterday we talked about with horizontal asymptotes? Had something to do with the degree on top and the degree on bottom. What's my degree on top? 1. What's the degree on bottom? 2. So the degree on top is smaller than the degree on bottom. So my horizontal asymptote is going to be at y equals 0. So this right here, that's my horizontal asymptote along there. But notice we do happen to cross it. So there are sometimes exceptions to the rule. So it's like, hey, this works for the whole graph except for that point. Okay? It's still a horizontal asymptote. It still follows the rules of a horizontal asymptote. It's just we happen to have a crossing. And the reason that crossing takes place is because we do happen to have a variable in the numerator as well. That variable in the numerator wasn't part of a binomial that made a whole or anything like that. So we have horizontal and vertical asymptotes. Okay, horizontals here, vertical are these two. Our sign line, when we look at this, we could say where we want values less than 0. So we want to know where this is negative. So it's negative from negative infinity to negative 3, rounded bracket because it's undefined at negative 3. And then it's negative also from 0, but square bracket at 0 to 3, round bracket. That's where this answers this question here. Okay? Why is it a square bracket at 0? Well, 0, 0 exists. Okay, even though we have that horizontal asymptote, it's like, you ever been someplace where you're playing a game and you have rules for everybody, and then there's one kid that you have a special rule for? The kid we used to hang out with named Ken Vogelsang, he had like a knee brace on, so we weren't allowed to tackle him. But it wasn't like one of the cool knee braces that they wear in sports. It was like he had like a curve in his femur, and it was trying to correct it, so we weren't allowed to tackle him.
Like that.
So we had to make rules up. You only had to tackle him once, and you get steel shank in the side of your face. You're like, oh, it hurts. So that's why we made the rule, because someone lost an eye almost. But let's face it, if someone almost loses an eye, that's just downright funny as friends. All right. What else on this homework on the front or back? Do what? Anybody? Going once? Anybody going twice? Anybody sold 3 times?
Landon is.
What do you got, Landon?
Which numbers are we supposed to do? Let's do them all.
Evens.
Let's do 10.
10A and B? I'm with you. Give the domain of each function. That's all I want us to find. Okay, so 10A. 10A gives us f of x equals x plus 1. And 10B gives me f of x equals square root. Okay. All we want to do now is find the domains. So if I'm looking at the domain, I'm just looking at the denominator. What's the only value that's going to make the denominator on A become 0? -1. If I plug -1, and it doesn't matter what happens on top, on bottom it gets -1 plus 1, which is 0. So -1 is the only thing that doesn't work. So my domain on the first one goes from here. And that's all you have to write for it. It's rounded brackets as in 1s because I can't include it, but I include every other point. The domain on the second one is a little bit different to think about. So is this the difference of 2 squares? Is this x plus 2 and x minus 2 if I factor it? Remember that from Algebra 1? I don't care who your Algebra 1 teacher was, unless it was me, Abby. Can't blame me. All right, so does everyone feel okay about that factoring? So, my friends, what's going to happen? What's going to happen if I plug values from -2 to 2 in? Okay? So, can I pick 0?
Sure.
0 squared minus 4 is -4. Square root of -4. Can I add the square root of -4 as far as the real numbers go?
No.
No. So between this region, if I plug values in between this region, if I include these 2 points, that's fine, because I can have square root of 0. That's fine with me. So this exists and this exists. Okay? Nothing else exists in between them. But if I plug further out negative numbers, so if I plug like -10 in, I'd get -10 squared, which is 100. 100 minus 4 is 96, so I get root 96. Root 96 might be an irrational number, but it's still part of the real number system. Okay? So I can plug anything in I want to this up to -2 and square bracket. And then I can't plug anything between -2 and +2 in. Because I plug either of those values in, any of the values in between -2 and +2, I'm going to get a negative underneath the square root sign. Okay, and that's all that we're asking for on that problem. Okay, of course, you just have to recognize the difference between 2 squares. I would say either one of those problems would be fair game on Monday. And on those problems on Monday, I would have it as a multiple choice. And I'd say, what's the domain? And so I'd probably say, list all that are correct. So I'd have probably like -infinity to -2. And then another choice would be 2 to infinity. And then I'd have just other answers that would go along somehow with the problem. But you'd have to mark all that would be correct. Okay? So I think this is definitely one that I would see on Monday. This one I think we could also see on Monday. But letter A, you might see on Monday. There might be 4 problems that are similar to that. And I might say match up the domain with the answers. So 10A might be like a matching. 10B would be a multiple choice where you mark as many correct. And I think the quiz will be 10 questions. And I think they will all be multiple choice of some sort. They won't be any short answer. You might have true, false. You might have matching. But you won't have... The hard thing on that last quiz was some of you put like the totally right answer. Like let's say the answer came out to x plus 5 and x minus 2 factored out. You put x plus 5 space x minus 2. And of course, Schoology doesn't understand spaces. So I had to go through and say yours was correct. So I had to override it. But that's fine. All right, anything else off the homework you want to take a look at? Okay, put your names on it. Put your names on it, please. And pass it on forward. Today's Thursday, right? Wednesday? All right, so for this evening, because we're almost out of here, I'm going to assign you graphing, review, number 2. And I don't know how many problems are there.
Oh wait, no, there's 13.
So let's do the odds. Cool, are we good? I'm going to be done recording here.